All right, so section 5.3, we're going to be talking about inverse functions. So this is something that you should have talked about in honors pre-calc. You know, how do you know if two functions are inverse functions, or how do you know if a function has an inverse, or basically finding inverses of functions. So we're going to do this. We just finished up derivatives and integrals of logarithms, mainly natural logarithms. So we're going to talk about inverse functions before we move on to exponential. So let's go ahead and get started on this. So hopefully these are some things that you remember about inverse functions. First of all, the domain and the range are switched. So in the function f of x, let's say we have this point, I don't know, 2, 5. In the inverse, now make sure that you're careful with your notation here, because I do it too. I get my inverse and my derivative notation mixed up. We're looking here, f to the negative first power. So in the inverse function, we would have the point 5, 2. Okay, your x and y values are switched, which just means your domain and range are switched. And then in pre-calc, you should have talked about this concept that if we do function composition, meaning if f and g are inverses of each other, when we take the g of x function and plug it into f, or we take the f of x function and plug it into g, we should end up with x. Okay, that's kind of how we know if two functions are inverses of each other. So like x squared and square root of x. If I have f is x squared and g is the square root of x, if I take this and plug it in here for x, or I take this whole function and plug it in here for x, you can see that our answer will just be x, okay, because they are inverses of each other. There's a little bit more that goes into that, because x squared technically doesn't have an inverse. We would have to define that for all x values that are greater than 0, but we'll get into that stuff later. The last one here is just sort of our notation for an inverse function. And what I'm going to do is, a lot of times we're asked something like this, f inverse. I'm replacing that with g, and I'll say, f and g are inverses. Instead of using f and f inverse, because we're going to have to do f inverse prime, and that notation gets a little messy. So I will often switch f inverse with g. So just keep that in mind. All right, so if we're given f of x equals 3x plus 2, how do we find the inverse? Hopefully you remember this, but if not, that's okay. We're going to go through this. So basically what we do is, this is the same thing as y equals 3x plus 2. So you could do one of two things. We either switch the x and y and then solve for y, or we take this first, the way this is written, solve for x, and then replace it, and then switch the x and y. So it doesn't matter. You're doing the same thing. It's just the order that you do them in is a little different. So we're going to subtract 2 and then divide by 3. So we get x minus 2 over 3, which you could write it as 1/3 x minus 2/3, doesn't matter. So that's how you find inverses. You either switch the x and y and then solve for y, or you solve for x and then switch the x and y. It doesn't matter. You end up with the same thing, so it doesn't matter. All right. Now, how do we show that functions are inverses of each other? Well, like I had said on that second slide, we're going to take this 2x cubed minus 1, and we're going to plug that in here for this x value. So we're going to do g of f of x, and we're going to show that this is equal to x. Now, you could do just the opposite. You could do g of f of x. Doesn't matter. Basically, that would require you to take, let me erase this stuff here. That would require you to take this whole thing right here and bring it over here and plug it in for x. Doesn't matter. You do whichever one you want to. Show that it's equal to x. Okay, so I'll just write out the work here. I'm going to do g of f of x, which means I'm going to take the cube root of x, which I'll replace 2x cubed minus 1. And I'm going to plug that in there for x and write out the rest of the problem. So plus 1 over 2. Okay, so then after I do that, the minus 1 and plus 1 cancels. So I'm left with cube root of 2x cubed over 2. Then my 2's cancel out, so I'm left with the cube root of x cubed, which is just equal to x. So since I ended up getting x, which is what I wanted to get, that means that they are inverses of each other. And you would get the same thing if you did it the other way and you took this and plugged it in here for x. You would still end up getting x for your answer. Okay, so that's how we verify that two functions are indeed inverses of each other. Now, how do you know if a function has an inverse? We know that only if it's one-to-one. So what does one-to-one mean? And basically one-to-one mean, so first of all, we know that a function is a function if it passes the vertical line test. We know that it's one-to-one if it passes the horizontal line test. So which of these has an inverse? And if it's not something that you can go through and really attempt to solve for x, or switch the x and y and then solve for y, really what we need to do is look at a graph of it. Okay, so I'm going to pull up the graph here. Let me make this fit in the screen here. Whoops, wrong button. So what we're going to do is we're going to take this, these two functions, and I'm just going to graph them on Desmos. You can use your graphing calculator, but this is easier for me to work with on my laptop. So here's my first two functions, x cubed plus x minus 1 and x cubed minus x minus 1. If I look at both of them and I zoom in here, we can clearly see that this green one, if I draw a horizontal line, the green one is not going to pass the horizontal line test. That means x cubed minus x minus 1 will not have an inverse. Okay, x cubed plus x minus 1 will have an inverse. We're not going to find it, but we could find an inverse for that blue graph in some way or shape, but we're not going to worry about that. We just wanted to know which one is possible. So, sometimes we have to do that by hand. Now, some of the graphs, okay, so we know A would be the one that does have an inverse. Some of the graphs we know, like if we have an x squared function, we know that this graph is going to look like a parabola and it's not going to pass the horizontal line test. And that's why I said in that earlier one, x squared and the square root of x are inverses, but we have to kind of restrict the domain to where the graph starts to become a mirror image. Okay, so if we do that, then we can make it be something that we can find the inverse of, which is kind of, if you think about the sine, cosine, and tangent, you did the same thing there. So, I mean, if we look at the sine graph, the sine graph and the cosine graph look like that. I mean, that's a terrible graph of it, but you get the idea. If we draw a horizontal line there, it's going to hit the graph more than once. It's going to hit it infinitely many times. So what we do then is we kind of restrict the domain of the sine and cosine and tangent graphs so that we can find the inverse functions. Okay, and that's why if you remember the when you were doing sine inverse, sine inverse was only defined in quadrants 1 and 4, cosine was defined in 1 and 2, and tangent was defined in 1 and 4 for that reason, because we restricted the domain so that we could find inverse functions. So hopefully I'm telling you a lot of stuff that you already know and you remembered from pre-calc, but if not, you may want to look over that stuff before we get into our inverse functions a little bit more. So, all right, let's go on to our next stuff. So what happens, now let's apply calculus to this. What happens if we take a derivative of this? Okay, we've done a lot of derivatives. So f of g of x, what happens when I take the derivative of both sides of this? Well, hopefully the right-hand side we're like, okay, well the derivative of x is 1, so that's an easy thing. On the right-hand side, we have a function, g of x, inside of a function, which is f of x. So we have to use chain rule here. So we do the derivative of the outside, so f prime, and we leave the inside the way it is, x. And then we multiply that by the derivative of the inside, which is g prime of x. Okay? This is a very important piece of information that you will need to know. Okay? Now, you can derive this. That's where the word derivative comes from, deriving. You can come up with this formula just by knowing this piece of information that you learned in pre-calc. But this is something that we will use a lot, mainly in the rest of these notes, but I can guarantee you will probably see a problem like this, probably like over a 90% chance that you will see a problem like this on your AP test, okay? So let's go through some of this stuff here. Well, let's first of all look at this. Let f of x equal 1/4 x cubed plus x minus 1. What is the value of f inverse of x when x equals 3? So if this is asking you, now look, we can plug 3 in here, right? We could do 1/4, 1/4 times 3 cubed plus 3 minus 1, right? 3 cubed is 27, so we get 27 over 4 plus 2 would be 35 over 4, I think. I don't know, just doing some quick math there. So we have this point 3, 35 over 4 that lies on this graph. Now, if you were asked to find, the inverse, we're asked to switch these, but we're not just going to switch the x and y here, but what we're going to do is we're going to see where does this graph equal 3, okay? Because f inverse of x, when x is 3, we're asked for the inverse function, which means we're asking for the y value, so that means the x value becomes the y value. So we're going to do 1/4 x cubed plus x minus 1, and again, since I'm in the inverse function, x values become the y value. So I'm going to set this equal to 3 instead of plugging it in for x like I did up here in the original function. For the inverse function, the x values become a y value. So I set it equal to y, or I set it equal to 3, and then I'm going to go through and solve this. So let me move this down. That's my next question here. So let me go through and solve this now. Let me move the 3 over. So 1/4 x cubed plus x minus 4 equals 0. And I'm going to multiply this by 4 just to give me some easier numbers to work with. So x cubed plus 4x minus 16 equals 0. Now, how do we find out how this, or where this is equal to 0? Since this is an x cubed and not an x squared, we're really only limited to one option, and that is, again, something you learned in Algebra 2, and you may have revisited it in Honors Pre-Calc, and that is the rational root theorem, which was kind of a very painful problem to process to do, because we take this last number, and we take all the factors of it, so plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. And we divide them by the factors of the first number, which is 1, so plus or minus 1. These are all your potential zeros. You remember doing this, hopefully? They're not very fun problems to do because they were basically our last resort in factoring polynomials. We basically ran through a bunch of other options and tried to find another way of factoring, but if nothing else worked, we were kind of stuck with the rational root theorem. So this is what we did. Now, from here, just to finish out this problem, what did we do? Well, we took our factors, like 1, and we tried to see we use synthetic division, so that would be 1, 0, 4, and negative 16, and we tried to see which ones gave us a remainder of 0. So hopefully you remember how to do synthetic division, because I'm bringing up a lot of stuff from Algebra 2 and pre-calc here that you're kind of expected to know. So if I'm doing something you don't have any idea what's going on, you need to let me know so we can get you caught up, okay? So multiply 1 times 1 is 1, and then this would be 1 times 1 is 1. Add those together, you get 5 times 1 is 5. So we end up with negative 11. So all this tells me is that 1 did not work. So then I go on and I try negative 1. And I say 1, 0, 4, negative 16. These numbers, 1, 0, 4, and negative 16, they're the coefficients of these, okay? So 1, why do I have a 0 there? Because there is a 0x squared. Remember, if you're missing a term, you got to fill it in with a 0. So there's a 0x squared in there. So that's where that's coming from. So I bring down the 1 times negative 1 is negative 1. 0 minus 1 is negative 1 times negative 1 is 1. 4 times 1 is I'm sorry, 4 times 1 is 4. I'm sorry, yeah, no, add, sorry. Let me back up. 4 plus 1 is 5. 5 times negative 1 is negative 5, which is not 0. That's a negative 21. So negative 1 doesn't work. Now we go on to our 2's, and you can probably see by now why this is a really, really, really annoying problem to do. So I go on to 2, and I'm using my same 1, 0, 4, negative 16. Bring down the 1, you get 1. Times 2 is 2. So 0 plus 2 is 2. Times 2 is 4. 4 plus 4 is 8. 8 times 2 is 16, so we got it. Okay, we got a remainder of 0. So now we know 2 is a factor. Okay, we haven't even answered the question yet. 2, we just know that 2 is a factor. Okay, so what we're going to do then, just to kind of speed this up, is I'm going to come back up here to this problem, and I'm going to plug 2 in and see if I get 3. Because if I do, then I know I'm done, and if not, I got to work with some of these other factors until I find one that gives me 3. So I got 1/4 times 2 cubed is 8 plus 2 minus 1. Let's see what this gives us. Well, 8 over 4 is 2 plus 2 minus 1 gives me 3. Yay, we got it. So that's what we wanted, okay? So now we know in the inverse function, we have this point to 3. Okay? Which actually should have given me, maybe I did something wrong here, I don't know. If the inverse function has the point 2, 3, then that means the original function should have the point 3, 2. But I don't know, maybe I messed something up there. Anyway, this is what we were looking for, okay? So the value of f inverse of x when x is 3 means that in the original function the y value was 3, so then the x value would be 2. Okay? Now, let me come down here to the second part of this question. What is the value of f inverse prime of x when x equals 3? So again, what I'm going to do is I'm just going to make a little side note over here. I'm going to say f and g are inverses. Okay, f and g are inverses, because that allows me to say g prime of x. Okay, and it kind of simplifies our writing here. So what is the value of g prime of x when x equals 3? So that means I'm going to go back to my f of g of x. If those are inverses, that means they equal x. So f prime of g of x times g prime of x equals 1. And now what I'm looking for here, since I've renamed this g prime of x, is I'm going to solve this for g prime of x. Okay, so what is g of 3? Well, we just did that up above. That gave us 2. So now I'm going to do f prime of 2 and see what I get. So what was f of x? Well, that was my 1/4 x cubed plus x minus 1, if I remember right. Let's come back up and check. 1/4 x cubed plus x minus 1. Yep, that's what we got. So we need to take the derivative. So I get 3/4 x squared plus 1. So what happens when I plug 2 in here? Well, I get 3/4 times 2 squared is 4 plus 1. So they cancel. 3 plus 1 gives me 4. So that means f prime of 2 is 4 times g prime of x equals 1. And our goal was to get g prime of x, so g prime of x is equal to 1/4 when I divide both sides by 4. Okay? Now, I know I went through that kind of quickly, so if you need to, rewind it, watch it again, pause through each of the steps and make sure that you understand what's happening there. But we're going to go through some other examples that are similar through tabs and just through other stuff here, or through tables, tabular. So in 2008, this question was on the AP Calc exam. It was number 28. Not that that matters, but this is the type of problem that you can expect to see. Let f be a differentiable function such that f of 3 equals 15, f of 6 equals 3, f prime of 3 equals negative 8, and f prime of 6 equals negative 2. The function g is differentiable, and we're told right here g of x is the inverse of f of x. What is the value of g prime of 3? So again, we're asked for an inverse derivative. Whenever you see an inverse derivative, this is what you should automatically be thinking of. Inverses and then take the derivative. F prime of g of x times g prime of x equals 1. This is what we are trying to solve. Or this is what we're looking for. So if you want to pause the video and try it, I would recommend you do that and see what you get. All right, so g of x, we're looking for g of 3, so I'm just going to replace this x with a 3. So g of 3, remember, if we have g of 3, this is an x in the function of g, which means it was a y in the function of f. Right here is the only y value that we have for 3 in f. So that means f had this point 6, 3. Since g is an inverse, that means it has the point 3, 6. So what is g of 3? And that is 6. So f prime of 6 times g prime of 3 equals 1. So now we come up here and we see, okay, well, what is f prime of 6? Well, f prime of 6 is negative 2. So we have negative 2 times g prime of 3 equals 1. That means that g prime of 3 is equal to negative 1/2. Final answer. Next one. Here I just have like 3 examples of practicing this same concept and, just seeing, what do we get? So we have to go through the whole process of saying, all right, if I'm looking for an inverse derivative, and again, you can just say this g of 9, that means the function f, well, let me change the color there. F has the point, I don't like that notation, let me do that again. F has the point 9, or I'm sorry, something 9. That means that g will have that point 9 something. Okay, because they're inverses. So I'm going to start off by taking this and setting it equal to 9. So 2x equals 4, therefore x equals 2. Okay, so now I know f has the point 2, 9. That means g has the point 9, 2. Okay? Now, for functions like this, it's pretty simple for you to find the inverse, but sometimes it's not possible to do that, so we have to be able to do this whole process here. So, again, I'm going to go back to, let me kind of separate this here. I'm going to go back to my f of g of x equals x, and I'm going to say f prime of g of, I'm looking for 9, is equal to, whoop, back up, times g prime of 9, which is our answer, that's what we're looking for right here. Okay, g, there should have been a prime here with that, equals the derivative of x is 1. So what is g of 9? We did that right here. G of 9 is 2. So I'm looking for f prime of 2 to get our answer. So f prime. So what is f prime? Come back to your problem. F prime of x is 2. So f prime of 2 is 2. F prime of anything is 2. It's always 2. So I end up with 2 times g prime of 9 equals 1. Therefore, when I solve for g prime of 9, divide the 2 over, I get 1/2. Okay, so that's your final answer there. Now, these last two, go ahead and write that one down. And this one. I want you to try those. I will put the answer in the message when I send out the video. Do these two problems. Here's one of them, x squared minus x plus 4. Find f inverse prime of 4. Follow the same steps I just did in the last problem. Here's the last one, x cubed plus x plus 4. find f inverse prime of -6. Again, follow the same steps I did in that last problem. I will put the answers in the text box of the message on your Google Classroom when I send this video out to you. So you can check your answers there, and if you're still not sure how I'm getting the answers, let me know and I will go over it with you. But I want you to try these, so try them on your own and see what you get. The last one that I want to do with you here is a table. So AP loves, College Board, AP, whatever, they love doing table problems. So again, f inverse prime of 6 given this table of information. So remember, we're going to do f of f inverse. See, I even get messed up when I do this. F inverse of x equals x. So let's start this off. F prime of f inverse of x times f inverse, see, I did it again, f inverse prime of x, derivative of x is 1. So let's see what we got here. I'm looking for when x is 6. All right, so let's start here with our f inverse of 6. Okay, let's get this part right here, f inverse of 6. So here's f inverse of 6 is 2. Okay, so I have f prime of, I'll try and color code this so you can stay with me, 2 here we go, 2 times f inverse prime of 6 is what we're looking for, equals, this is not an x because I did the derivative in that step, that should be a 1, 1. Okay, next step, I need to determine f prime of 2. So f prime, here's f prime of 2 is 4. So f prime of 2 is 4 times f inverse prime of 6 equals 1. So that means my final answer, f inverse prime of 6 is equal to 1/4. Okay, so there's your final answer for that one. Here's some more problems to try. Basically, you got a lot of inverse stuff going on in here. I may have added some extra inverse stuff that is not just the calculus stuff, maybe some earlier Algebra 2 or pre-calc inverse stuff. So if you're having trouble remembering that, let me know and I can help you out with it. But yeah, so here you go. Here's some problems, and just let me know if you have any questions.